Okay, another thing about this. Remember we talked about the session and your workspace, and we said that you've got an electronic bucket, and all these variables and things you're using are available to you and floating around in this electronic bucket. When you call a function, that workspace, that session, you can think of it as an environment. It is. It's an environment. It has space. It has scope. Scope is the word. It has scope. Everything in the environment is within scope. The global environment is the thing we saw when we did the search command. Remember, we did search, and we saw the list of packages that are floating around. We saw this one. This is the big mama. This is always number one. It's the top level environment or space. But when you call a function, as soon as the function begins to execute, this goes to sleep. It disappears temporarily, and all of the variables and all of these objects that are in this space also disappear. And a new environment is instantiated. It's the environment of the function. And you wipe the board clean, so to speak. And as you create variables within the function, those get instantiated into the new environment. It's a completely different environment. Think of them as two separate sessions, because they are. The global environment or session is separate from the local environment that gets booted up when you call the function. But they're not separate side by side. They're nested. The function environment, the global environment is the parent to the function environment. And if you call a function within a function, which you can do, we could call a different function within this function. We could even call the same function within the function. It opens up yet another environment. Every time you call a new function, you wipe the slate clean, and you're starting over in terms of defining variables, packages, everything. This is where it gets interesting. Okay, and so scope means, where do your variables have value? Where do they have value? And R is unique because here's the short rule. The global environment, the parent environment, cannot see the values of the variables in the function. The top level environment is unaware of the value of k or n or any of these local variables. But the opposite is not true. The function, if it needs to, the local environment in the function, if it has to, only if it has to, can look in the global environment and see the value of variables. Okay, but they're separate. Okay, so scope is important, and we'll talk a lot more about that. Okay, now so what does that mean? Okay, what are the implications? Let's look at an example here. All formal parameters are local. Okay, here's an example. We wipe the slate clean, so I clear out all the objects. So our global environment's got nothing. And I'm calling a function. Note that if the body of the function only has one statement like this one does, you don't have to use grouping brackets. you can dispense with them. If you have more than one statement, you should put one statement on a line and put them in the grouping brackets. But if you only have one, like this one. So what does this function do? Here's our function, f. Well, it takes a parameter and it adds it to y, and it returns that. That's all it does. Okay, well, so let's load that in. So we'll load in function f. Okay, so here's function f. It's in our environment. And so now in the global environment, we haven't called f yet. In the global environment, we'll do this. Let's create a variable called z, and we'll assign the number 3 to it. Okay, so we've got z in our global, and we have function f. Okay, now we're going to try and we call function f, and we're going to pass a value of 5. What's going to happen? It fails. What happened? Well, we called the function, x became 5. It came here to this statement, and it said, okay, I need to add 5 to y, and it looked within the scope of the function and did not find a variable y. Only at that point did it look up to the next parent, the global environment, and said, is y floating around there? And it's not. There's no value of y there either. So it gives up, fails. Okay, let's try that again. But this time, in the global environment, we'll create a variable y and give it a value of 3. So now in the global environment, not the function, we've got this variable y, which has a value of 3. So we call f again. What happens this time? Well, this time it succeeds, and the function returns a value of 8. And you say, well, I get that, Jeff. It added 3 to 5 and returned 8. Yes, it did. But y is a free variable. Remember, we talked about formal, local, and free. Y, when it calls f, when we call f here, y it does not have a value. Y has not been bound, instantiated. That is, x has a value of 5. It gets to this statement, and inside the function, in the local environment in the function, it says, I need to add 5 to y. What is y? Well, it looks around in the function, it doesn't know. Y doesn't have a value. So only at that point, when it needs a value in order to continue, then it looks up to the parent and says, do you have a variable called y in your global scope? And the parent says, yes, I do. It's 3. So it says, okay, well, I need to borrow that value, so it adds the value of y, which is not in the function, and returns it. Okay, why do we care about that? Well, let's look at a couple of things. First of all, once the function gets called, and it returns this, 8. What is, at that point, what is our value of y? Let's take a look. So we look at the value of y. Y is still 3. Y has not been changed. Well, what happens if we did this? What happens if we called the function again, same function, we don't change it, but in the global environment, apart from the function, y has a different value. Now y is 7. And we call the function again with the exact same parameter, 5. What happens then? Now the function returns a different value. This is not good. Okay, you have to be very careful. You don't want your function to return values that are not determined within the function itself. Now, sometimes, people, it depends on who you ask. Some people will say, actually, this is a good thing because you can use this flexibility of depending on the values in the global environment to have your function do different things. Well, that's true, but it makes it really hard to test if you have, a complicated program with a lot of functions, because you don't know the state. What we're talking about when we're talking about the values of variables in an environment, we're talking about state. State is the total set of the unique values in an environment. So what you have in this case is what the function does depends on the state of the parent, which is not good. Okay, functions should be cohesive, and functions should be loosely coupled, which means they should not be dependent on other things, on other functions or other environments. That's where you lose control. So you got to be real careful about this. Okay, so that's important. Let's look at something else. Okay, R is unique, and I would argue better than many programming languages in its flexibility with functions, with programs, because you have a number of characteristics that are really useful, that build in a lot of flexibility. A couple of those are so-called lazy evaluation of arguments. Let's look at this feature. Functions, you can define a function, and when you define the function, you can give the formal arguments default values. All you have to do is name the argument and assign it a value when you define the function. So if I define a function like this, and we're not even going to worry about what it does, what the body does, there are three arguments, x, y, and z. It's function g. But by providing two of the arguments with default values, I can call this function g and just not even be aware of these two arguments and not call them. I can call this function g with only one argument, which becomes x, and it will still work. It will automatically instantiate a local variable called y that has a value of 2, and it will automatically instantiate a local variable of z that has a value of true. I don't have to be aware of it, or even I don't have to deal with it. Okay, and we'll talk about this more. This is a nice feature. Let's look at some examples. We've got a couple of minutes. Okay, I didn't quite think I'd get this far. Bear with me just a moment here. Let me find. I've got some good scripts on this. Let's look at a couple of implications of these default value arguments. Okay, here's a function we're creating. It's called CarePlot. And what it does, there are four formal arguments, x, y, pc, and co. What the function does in the body is it creates a scatter plot. That's all it does. It calls the plot function in the base graphics, and it plots y on the vertical and x on the horizontal. So you get a scatter plot. And the plotting character, PCH, is an argument for the plot function. The plotting character is going to be this value, and the color is going to be this value.